Good day, my name is Jemima and I'll be doing part 1 of the Kinetic lab. The first thing I'll be doing is making the vinegar and water solution. So like I said, I have 2 cups of water here and I'm adding 1 cup of vinegar into it. And the purpose of this experiment is to understand how temperature affects the rate of reaction in the reaction between baking soda, which is sodium bicarbonate, and vinegar, which is acetic acid. So we learned in class that increasing the temperature in a reaction will increase the rate of the reaction. So that is what I believe is going to happen here. One of these bottles will be placed in the refrigerator for 30 minutes and one will be used right now for the room temperature part of this experiment. So the room temperature bottle will be going first. What I have here is my timer. I'll be using my tablet as the stopwatch. What I'm doing here is wrapping the balloon around the mouth of the bottle very carefully to make sure that none of the baking soda goes into the vinegar solution before time. This reaction starts as a double displacement reaction when sodium bicarbonate reacts with acetic acid to produce sodium acetate and carbonic acid. The carbonic acid then undergoes a decomposition reaction when it decomposes into carbon dioxide gas and water. I started the reaction at 0 seconds and stopped it at exactly 20 seconds. As you can see, I was struggling to pull the balloon off of the mouth of the bottle because I didn't want any of the gas that was inside the balloon to escape. So I quickly tied it and then I got to measuring it. What I have here is my timer. I'll be using my tablet as the stopwatch. What I'm doing here is wrapping the balloon around the mouth of the bottle very carefully to make sure that none of the baking soda goes into the vinegar solution before time. This reaction starts as a double displacement reaction when sodium bicarbonate reacts with acetic acid to produce sodium acetate and carbonic acid. The carbonic acid then undergoes a decomposition reaction when it decomposes into carbon dioxide gas and water. Now I'm doing the warm sample, which I put in the microwave for 1 minute. The same exact procedures will be followed with swishing it around for 20 seconds and then taking its measurement. Now I'm doing the cold sample, and again starting at 0 seconds, stopping at 20 seconds. The cold sample actually took about 14 seconds to start collecting gas. The reaction was very slow compared to the room temperature one, and especially compared to the warm sample. Now I'm just simply taking its measurement as I did with the first 2 balloons. Calculations done were made assuming the balloon has an approximately spherical shape. Okay, so after doing calculations, I will be inserting pictures right here. So as we can see, at different temperatures, different amounts of gas were produced. More specifically, that at a higher temperature, a greater amount of gas was produced This is what I predicted would happen, and as we can see by the graph that was sketched, the higher the temperature, the higher the rate of reaction, because the increase in temperature causes the particles to spread around and move faster as they are gaining kinetic energy. So, by this, we can see that temperature has a direct proportional relationship with the rate of reaction.
My name is Gianni, and I'll be discussing part 2.
All right, good afternoon, class. I'll be doing the effect of concentration on volume of gas. Today, our independent variable is going to be the vinegar that we will be serially diluting. Our dependent variable is going to be the volume of gas that is produced, and we are going to control the variables of temperature and the amount of baking soda we add to each balloon. So the baking soda, we're going to be adding 1 tablespoon to each balloon. I'll probably try to add it in right now, but if it takes too long, I'll do a little bit of editing magic to speed it up later on. For the sake of time, I went ahead and done the serial dilution already. But basically, to do the serial dilution, I added half a cup of vinegar into this measuring cup, put it into my container, and then added a cup of water and added it to the vinegar. Now, from this diluted vinegar solvent, I then took half a cup of this diluted vinegar and added it to this black cup. Then I proceeded to add a cup of water into the measuring cup and added it to this mixture. And then to get the final concentration of vinegar, we took half a cup of this concentration, added it to this cup, and then mixed that with 1 cup of water. And that allowed us to do the serial dilution. And so each one of those concentrations of vinegar will be going into bottle A, bottle B, and bottle C. But now I'll begin the process of putting baking soda into these balloons. Like I said, if it takes too long, I will just speed it up in the post edit. And voila, our balloons are all full. So now what we will do is put 1 cup of each of our solutions into these bottles in front of me that I have labeled. The first one is okay, so we can actually begin the experiment now by putting the first balloon onto our concentration A. So this is the one with the highest concentration of vinegar. What we'll do is that we will use a stopwatch to count down to 20 seconds. We'll allow the baking soda to mix inside the concentration of vinegar. And at 20 seconds, using this black cable, I will measure the circumference of the balloon. Of course, then I'll properly measure it with a measuring tape and use the circumference to calculate the volume so we can see how much they actually expanded. So let's begin. All right. So first, we'll add all the baking soda. There we go. Just gonna hold the balloon so no air escapes. Let's mix this up a little bit. I think we might have some air escaping, but not to worry. Okay, got our measurement. Just going to use this measuring tape to record it. And it comes in at 11 inches. So I decided to speed
this part up simply because I just want to do the same process 2 more times over. While I talk about what I expect to see, which is that we expect that the bottles with lower concentration of vinegar to produce less gas, less product, simply because there are less solute. There is less solute on a whole for collisions to occur. So the collision theory states that if you have a higher amount of particles, you'll have more collisions, which will produce more product. But in this case, as we predict, we expect that the lower the concentration, the less product, the slower the rate, because there is just less chances for collisions to occur, which means there's a lower chance for reactions to. The reaction is just slower. So these are the results of our calculations. As you can see, I was able to calculate the sample concentration for A, B, and C. The volume of the gas, which was calculated by using the circumference we measured to get a radius for each balloon, and then we utilized the radius to then find the volume. And we did that by assuming that the balloon was a sphere and multiplying 4/3 by pi, and then multiplying that by the radius cubed. That gave us the volume that we needed in order to do our graph. And also the rate of reaction, it was calculated by dividing the volume of the gas by the time that we took, which is 20 seconds. Moving on, here is the graph, which was plotted its concentration of the solute versus the rate of reaction. As you can see, there's a direct proportion with the concentration of the solute and the rate of reaction. And this can be explained very basically with the collision theory. In any given reaction, once you have a higher amount of solute, it means that you will naturally have more collisions simply because there are more chances for collisions to occur. And once you have more chances for collisions to occur, naturally you will just produce more product because the instances of two reactants meeting is simply higher. So it's basic proportion, and that would be the reason why the concentration of the solute is directly proportional to the rate of a reaction. Thank you.